Hi everyone, I'm Xiaoyu Chen from Huawei. On behalf of our team, I will briefly introduce our work at the WAT 2020 Indic Multilingual Translation Task from three aspects: data, method, and experiment results. First, in terms of training data, we train our model under the constrained condition and only used the two officially provided bilingual corpora and the officially provided monolingual data. The data size for each language is listed in the table. We followed the basic data pre-processing procedures: convert full-width text to half-width text, deduplicate the data, remove text which the source or target site is empty, perform language identification on the dataset, and remove text with undesired text, employ a multilingual sentence piece model for all languages, filter the corpora with fast align, and delete extra long sentences with more than 100 subtokens. The details of some of those strategies will be explained later. During the experiment, we observed that the model trained only with the PM India dataset performed much better than the system trained jointly with the PM India and CVIT PIB dataset. We believe the reason is that the domain of the PM India dataset is much more aligned with that of the test set. So we treat PM India dataset as in domain and CVIT PIB dataset as out of domain, and train a faster text classifier accordingly. By using this strategy, we try to filter out the so-called in-domain data from the CVIT PIB dataset. Our experiment proved that this strategy is effective. In terms of model, we employed transformer deep with base model parameters, plus a pre-LN. Our encoder contains 35 layers, while the decoder contains 3 layers. For our model, we trained a hybrid SPM in conjunction with English and 7 Indic languages as a shared word segmentation system for all languages. Regarding our English to multi-language model, we add text to target language at the beginning of the source sentence. For example, for English to Hindi translation, we add a tag of to HI at the beginning of the source sentence. When training multilingual models, there are basically two strategies: two models with English to multi-languages and multi-languages to English separately, or a single multi-language to multi-language model. We tested both two methods, and you can see our results in the table. Our experiment proved that the two separate models performed a little bit better than the single hybrid model. We did a domain transfer with a fast text classifier. Since I have introduced this strategy before, I will skip this part here. We assembled 4 models, a technique widely used, and we also employed language independent adapter to fine-tune our model. Previous researchers have found that due to the limitations of multilingual translation model, when we fine-tune one of the language pairs, the performance of others will go worse. Thanks to the simple and scalable adaptation method proposed by Babna et al. In 2019, we are able to fine-tune each language pairs without negatively impacting the performance of others. We set the adapter size to 128 and fine-tuned the model on the depth set for each language pair in the English to multi-language model. Here are our experimental results. We see a stable increase of blue improvements following our strategies. Particularly, our adapter fine-tuning strategy contributed to blue improvements in 2 languages, while the other languages are not impacted. In this task, among the 14 directions of the 7 Indic language pairs, our submission ranked the first place in 13 language directions. The English to Hindi direction even achieved an improvement of 10.5 in terms of blue when comparing with the baseline. Here are some takeaways from our experiment. First, we found back translation strategy did not work well on this task. Perhaps domain difference is the reason. In addition, a strategy of 2 models, namely English to multi-languages and multi-languages to English, is better than the multi-to-multi strategy, which is the same as the mainstream viewpoints. And also, we found data selection plays a more important role in our experiment when comparing with other strategies. Perhaps the test set represents a rather narrow domain, so the introduction of data from other domains will lead to a great shift on domain. So we refer to the static data selection ideal from curriculum learning and ensure little domain shifting while training data size increased. Here are the papers we referred to when conducting our experiments. That's pretty much of our work. Thank you all.